All right, we're here. Let's go. Look for some questions. Some stats. Let's see. It's a weird way to frame the picture. Ooh, it's about cats. All right. Histogram shows the distribution of masses in kilograms of 70 adult cats. And probably the cat chosen at random has a mass of more than 5 kilograms. It's a big cat. Oh my, what is this scale? Oh wait, no, they divided part in half. Okay, that's fine, I guess. I thought they were, I thought the distance between 5 and 6 was greater than the distance between 4 and 5, but it's not. Skirtle? You got that first. Congratulations. Wait. Oh, frick. I forgot to fix my Discord notifications. Okay, there we go. So probably the cat chosen random has a mass more than 5 kilograms. We have 70 total. You need more points so you can make you draw again. Gotta cop up the points. So for a mass of more than 5 kilograms, I guess we need to look. Oh my gosh, they make you count. So there's what? 4 bars, so each of these bars is 2, like 22, 24, 26, 28, okay. So if the 6, well, do we call it 5.5, I guess? It doesn't actually matter, we know it's more than 5. So that's 24 cats that are above 5 there, and up to 6. Now for up to 7, there's 4. So you do, I already forgot what the first number I said was. 24 plus 4 is 28. 28 divided by 70 is your probability. Same procedure for 6.5. Ugh. Then you really have to like guesstimate. Wait, are they asking? I assume this is something they typed and they want you. No, this is the solution? What's their question? Wait, you do 2 times 4 there. It's because you have 4 between 6 and 7. That's so unclear to me. Are those 4 total cats between 6 and 8? But they're saying there's 4 between 6 and 7 and 4 between... No, dude, that's not... That's terrible. That's a terrible way to show this data. There should be a bar there. Or that's just wrong, I think. Or is this their solution and I need to tell them that that's not right? Wait. Oh, what the heck? They're doing 3/4 times 2 times 4. It's not a problems estimate. We are assuming that the class is continuous when we interpolate, and that the probability being exactly equal to any. Ugh. This is... This is weird. Hey Krim, the best beard on Twitch, as of the beard off that I had with No Pro Bob, I think it was last week. It's now No Pro Bob who has that title. At least until I can challenge him again, I guess. Regardless, it doesn't look quite right. The histogram says there are 4 total cats between 6 and 8 kg, rather than 4 between 6 and 7, and another 4 between 7 and 8. Setting combinatorics currently. Oh, nice. Do you know Ian Stuckey? Because they are doing this combinatorics like reading group. I think it's maybe already started, but it's fairly early on. But in general, if you want to talk about combinatorics, I'm sure they'd be happy to like talk with you too. I know very little about it, but either way, I'm glad that you're enjoying it. So am I reading this histogram right? Yeah, like there's no bar there. Yeah, sorry, I only just like advertised to you, but since you mentioned like combinatorics, that's who like comes to mind for me. Because I wish I could talk to you like more about it, but I just like I can do like basic counting problems usually, and that's about the extent of my combinatorics knowledge. Hey, differential form, math stream, hell yeah. Saw you in Zach's chat. I'm glad to have you here too. You know, if you're interested in math streams in general, just let me give you a whole list of them there. There's even more than that, but those are the ones who I like know the best and can recommend. Yeah, if you're looking for more math streams in general, then there you go, and welcome into this one. Glad to have you. So this person has a geometry problem. QRST is a rhombus, which who the hell knows what a rhombus is offhand? Exactly. Rhombi or rhombuses, really? All 4 sides are the same length. Does that imply anything about the angles? I would think that the opposite angles are equal. Can you have like a scalene rhombus? Oh, it's a special... Okay, no, so the sides are parallel. Okay, so the opposite angles are the same. And yeah, if the sides are the same length, I think you gotta have equal angles, opposite. Okay. It's kind of a neat way of showing it too. All 3 of these are parallelograms, including parallelograms themselves. Every rhombus is a parallelogram, and every square is a rhombus. Okay. That's a crappy... Why did they draw it like that? That's just another square. They should have made it like tilted. That's just 90-degree... There's still 90-degree angles, like, visually. You know, maybe it's not to scale, and so like 89.9. but like, you don't, why they just rotated the square and called it a rhombus. Okay. I think a drawing could be a bit more clear, but the idea of it. Anyway, so we know angle Q is equal to angle S, angle T is equal to angle R. We're given the measure of angle TQP is 8b plus 53 degrees. I assume that's an angle bisector. In angle RQP is 10b plus 59. So would you equate these and solve? You could get b. What is STP? STP. Okay, so yeah, you could I would think that you equate these two to get b, figure out what the total angle is here over at Q. And then you know that the opposite angles are the same, and that the angles in quadrilateral add to 360. So you can figure out what this angle is down here based off that. So let's see what their work was, see how closely it matches. So they do seem to equate these. Let's make sure they didn't make an arithmetic error or even a copying error. 8b plus 53, 10b plus 59. Okay, good. Subtract the 8b over, subtract the 59 over. -6, +2, divide by 2, you get b is -3. It feels like a weird value for b, but I think it's just what you get. So we should get that these are equal regardless of which one we plug b into. So if you plug -3 in there, it's -24 plus 53 is 19? 29? 29. And -30 plus 59 is 29. Okay, good. So they're both 29. And so they divide 29 by 2? They should be, oh, they use right triangles, which I guess also works. But no, you do not divide 29 by 2. Oh no, they thought, oh, that's their mistake. They're taking 29 as the total RQT angle, but it's only half. So that's where their error is here. Other than that, I think I like their procedure. So they start with the angle QPT. They use the fact that this is a right triangle here to solve for this other angle down here. Now this should be 29 rather than 14.5. And then we know that this angle here should be the same as this angle over here, which is STP, which is what the goal was. Okay. Their procedure in general, but I want my angle symbol. Where is it in that list? Geometry, okay, there, angle symbol. TQP, RQP equals 29. Yeah, so I shamelessly stole it from this other subreddit that has all these listed out. But it's so hard to type things out in Twitch chat that I was like, I should really just get that as a command so people can copy paste them. Actually, let's get the degree symbol here too. As long as we're at it. There's no need to divide by 2. Divide by 2, you can just use the 29 degrees as you did in your calculations. 14.5. The entire angle, 29 is already half, or 29 degrees is already half of the entire, what did I say that was? RQT. Okay, I think they're otherwise fine. So let's post that and move on. And that one has an answer. Let's move on. That one has an answer. The intensity of infinite line source without using geometry tricks and using integration. Intensity of line source? They're talking about light? Or electricity? Yeah, I don't know what the heck they're talking about. Find the confidence interval. We wish to estimate what percent of adults reside in a certain country are parents. Okay. 500 adult resident sample, 268 kids. Construct a 99% confidence interval for the proportion pi. Oh god. Oh well, we can use pi. Oh my god, it even... Did they do that intentionally? It's even like... The midpoint of that is almost pi, isn't it? 3.221 plus 3.062. Oops. If this comes out to be 3.14, I'm gonna freak out. Oh my god, they're having fun. 3.145, it's right out to 4 decibels. Wait, 3.14159, yeah. So I mean they didn't round, but that's completely fine. It's actually, but apparently that's wrong. Yeah, this is the formula for it. Let's just plug it into a calculator and see if we get the same answer. I want proportions. Okay, 0.99, sample size 500, sample proportion 260, rounding to 3. Wait. Where did these numbers come from? How is a proportion greater than 1? What did they do? I was wondering why we're getting such different numbers. Did they take the actual number pi? Oh my, wait. Oh, they took the number pi itself. That's why pi is the midpoint of that interval. Wait, did they get the right numbers? Like, what is pi minus 0.46? Or maybe that's pi minus 0.046. Oh wait, no, the width of the interval is 6.06. So do they do pi minus 0.06? That... It's a mistake I could see myself. Oh wait. Maybe they did the interval slightly wrong, but I think they did something like that. Like they did pi plus or minus the width of the interval. They might have done 0.12? Like they didn't divide it in half? 3, 2... either way, that's why you don't use pi as something that's not the ratio of circumference to diameter, because you get confusion like this. You used pi equals 3.1415, which is definitely true in geometry. Actually, we can use the actual pi symbol here. However, the Greek, the letter pi sometimes gets used in non-geometry contexts to just mean some other number, confusingly. Here, pi does not mean 3.1415. When you calculate a confidence interval for proportions, you should expect results. You should expect either end of the interval to be a decimal between 0 and 1. The formulas you provided look correct, but instead of using pi, pi plus or minus the rest, you should use 260 over 500 plus or minus the rest. They're using pi... What did I just type? To mean the sample proportion here. They may have also blindly pressed the pi button on their calculator too. Okay, looks like this person got their answer. Hey, minority, how's it going? I'm doing good too. Thanks for asking. Just looking for a question right now. Oh, hey, Emiliano. I'm doing good. How about you? Yeah, sure, minority. And Emiliano, if you still have a question, please feel free to put it in chat there in YouTube or in my Discord. While I wait, I'm gonna put my mug away because I'm a lot of tea. Oops. Just kicked my desk. Oh, Emiliano, do you want to actually talk in Discord? We can do that. I just want to make sure that's like what you're what you want to do. It was a mistake? Okay, okay. No worries. Do you know how to use it? Oh, okay. um, Favorite subject of math? I wish I remembered it better, but I'd say my favorite subject is differential equations. And like specifically modeling with them. All right, so it looks like this is Emiliano's question. So choose a container model and keep it as similar as possible to something. This is the shape, dimensions, volume, and general details for the design of the new container. Following specification generation of the cost in dollars of the new material, the analysis material for the front, back, and sides must be of gauge 12. Okay, which costs 70 cents per foot. Per square foot, including any cuts or folds. Okay. Base material must be 10 gauge, which is 0.1345 inches thick, which costs 90 cents per square foot. The cover, regardless of dimensions, costs 50. Welding costs approximately 18 cents per foot of material and combined labor. That's what you've done until now. Let me make these bigger. Okay. So the volume Soldadura means welding? Okay. So I'm assuming some of these things and like some of the things up here are just like givens, like the volume is 10 cubic meters. Um, so let me actually, this might take me a minute to, oh no. Hey Jed. Ah, shoot. The bot isn't rotating the right image. Okay, you know, let me actually quickly do my minority suspects question because I think it's going to be a quick one, and then I'll come back to Emiliano. This is going to take me a little bit to figure out what's happening here. A bit of both, Jed, but more towards calculus. Okay, you chose the volume, Emiliano? Okay. So yeah, I'm just going to try and get this question out of the way here, and then I'll come back to yours. So minority, you're talking about question 45 here, which is this one. Y equals 8 arcsine x over 4 minus that disgusting thing, x root 16 minus x squared over 2. Okay. I'm finding the derivative of this. Okay. Oh, I see. So you're solving this for x, which is completely valid to avoid any arcsine tricky business. So from this stage, you take the derivative of each side. This is a... Well, it's a tricky one too. Shoot, I thought this would be a quicker question. So, okay, I guess this is still valid what you've done here, though. So we're doing implicit differentiation here. We're doing dy by dx. So the cosine, oh man, that's a weird situation. I would guess this is right. I wonder, like, cosine has the y's and the x's mixed inside of it, which makes it so much weirder. Oh gosh. And I feel like shouldn't there be, it should be 2 over 16 y prime plus this thing over here. Shouldn't it? Looks like this is all being multiplied. This chain rule part from the inside of the cosine seems slightly off. Um, Oh, this is where you're showing your work. Oh, you get a common denominator. Maybe you did do it right. Oh, that's what you did. I guess there's nothing wrong with that. I have a hard time following your work on the right side exactly, though, but I guess it's the right idea. Because why did 2y over 16 become 16 times 2y prime? And there's a 256 there. So I'm a little bit confused on that part. I'd expect the answer to be 2 over 16y prime, which actually, I guess you end up with that right there. Okay. Someone's on another page. Oh gosh, okay. So how do you go from this to this? You do the product rule on top. Root 16 minus x squared plus x times 2x, negative 2x over root 16 minus x squared. That's a lot to just do in my head. Two x squared minus 8 over 16 minus x squared. Okay, well, I'm just going to believe that then. Okay, so I guess I agree with this. And then you get a common denominator, which is valid. You multiply, that gets a root 16 minus x squared. I mean, I don't know if you necessarily even want a common denominator. Like, I would probably just leave them as separate because you're going to have to isolate y prime anyway. But this isn't wrong. You also rationalize the denominator. Or no, you factored out the 16. But then the 16 comes back. I don't know what's happening in that thing. Yeah, I don't know what's happening there, but it's when you move the cosine over. Yeah, this is such a weirder situation. Because if you're dividing, okay, yeah, I'm sorry, I'm not sure how cosine of that is going to evaluate to this, but I guess I can see how the 1/4 in that are connected. That's a lot of stuff inside the cosine that just kind of goes away. Yeah, it's up to you. It might just be a bit more instructive for me to solve it from scratch for myself too, but let me go back to Emiliano's problem. We got two complicated ones, so I'm not sure how to like juggle these the best, but because I hate to leave one of you waiting, but these are both like they both require a lot of like diving in. So I'm sorry about that, Emiliano. I thought it'd be a quicker one, but it's not. So let me try it with this one again. So, Emiliano, you were saying that you chose the volume to be 10 cubic meters. The shape, dimensions, volume, and general details for the design. New container. I'm not sure what the P is. But maybe I don't need to worry about it. Or maybe P is a consequence of the gauge. So this is getting maybe this is getting the volume of the total material to be used. So 2xy, because we have the front and the back, times 0.7, because that's the gauge. In Spanish we say pie? You're saying it pronounced it in Spanish? I'm not sure. Or just pi? But because in Spanish we say... Oh, that's interesting. That's the... Oh, okay, so you're converting it into feet. Oh, I didn't know it was abbreviated like that in Spanish. Honestly, I would expect you to just use like meters, but because feet are bad units, but cubic foot, okay. That's fine. So we have 2xy times 0.7, that makes sense. 2yz times 0.7, that makes sense. Xz times 0.9, because you only have one base, and that's the 0.9 gauge. Or that's the cost for that gauge. Rather, we're looking at the cost, not the amount of material to be used. Okay. So yeah, these two sides cost 70 cents per square foot. And this base, XZ, costs 90 cents per square foot. You have a flat $50 cost for the lid. And then where are these last three coming from? 2x times 0.18. Welding. Okay, so now we're getting into the welding. The welding is 18 cents per foot of material and combined labor. So the welds, we're going to have 2 welds of X length on this side and the back side on the bottom. We don't weld the lid on. We have 2 welds of Z length on the right side and the left side. Same, we also don't weld the lid on, okay. And then we have, now I think we need 4 times 0.18y. Because don't we have 4 welds for y? So we have that corner, that corner, that corner, and that corner. Or I guess edge. So it seems like we might need a 4 over here. No? Because we can fold it? Oh. Okay. Hey, hard locked. It's hard locked. Okay. Oh yeah, it does, including any cuts or folds. Okay. Then yeah, I guess we only need to, the other 3 are folds and you just weld it once. Okay. Then I agree with this setup here. So C of xy you could technically cut the metal into a plus shape and fold up the sides and only have to weld 4 times y. Oh, that would save you 1 weld, I guess. Because here you have 5 welds, there you have 4 welds, but I don't know exactly what's happening. I guess I don't know if there's a reason why, maybe it has to be like that for some reason, but I think what you're saying is true too, Jed. You could do the entire bottom as one big piece as a plus sign and just fold up the edges of the plus. Oh, wait, yeah, they're different gauges. You're right. Okay, never mind. So here we're taking the same thing, but we're doing this sub for z. Found a problem with Discord? Yeah. Which looks like a good idea. So now we get it into a two-variable problem that we have to optimize. And so this is just the cleaned up version of the last line. And now we have to get the partial in terms of x and the partial in terms of y. So let's verify these partials. 1.4 xy becomes 1.4y. That gets a negative sign in x squared. I like that. This is considered a constant, so it goes away. This becomes 0.36. This gets a negative sign and the x becomes x squared. Those are considered constants and go away. Okay, so I agree with the partial in terms of x. Partial in terms of y, that's 1.4x, good, that goes away. This gets a negative sign and a y squared, I like that. That's a constant. That gets a negative sign and a y squared, I like that. That gets a 0.18, okay, good. So I agree with c sub x and c sub y. I assume this is looking for critical points, something along those lines. So it's where both of these are equal to 0. So you multiply through by x squared y to get rid of the denominators. I agree with that. Okay, cool. Both with the context of the problem and a little bit of Spanish that I know, I'm able to figure out what things are, it seems. So this equation becomes this down here. So 14x. Oh wait, no, this equation is this equation. So these two equations are go with each other. So 14x cubed y squared. That becomes just that x. That becomes no variable, and this gets both of them, okay? Oh wait. Oh, good catch, Jed. All right, so Emiliano, I think this should be x squared because you're only multiplying through by xy squared. So I think that just becomes x squared y squared for right here. Should make it slightly easier to solve too. Once we have to do some kind of weird substitution in order to get this. Yeah, I should remember to get out saves. Okay. Yeah, sorry, my mistake. No worries. Glad that we or glad that Jed caught that. So add the 127 to each side, and then oh, you divided everything by x. I wouldn't. Dividing everything by x is dangerous. Or there should be an over x over here if you do that. So I think on the last line here you made a mistake where, I mean, I personally just probably wouldn't divide by x in the first place. But if you are going to divide by x, you need to have an over x for this 127 number over here. Oh wait, or am I getting it mixed up, Jed? Is it this line up here? Oh, my mistake. Sorry. I misinterpreted. Okay. Oh, but okay, yeah, and so this is this should be, instead of y cubed, it should be y squared. The powers are a bit off. So it should be x squared y squared here because it's just y to the 1 up here. Okay, so now, okay. I should have looked at the 319 changing to 484, I guess. So yeah, this last line is that first line. X squared y, that just becomes y. 0.36 x squared y. The 127 got added over here, and the denominator went away. Okay, so other than the power of y, I agree with that last line. Give a nice cancellation of the first term. Right. So it looks like Emiliano equated these, which... I guess is valid. They're both equal to the same thing. You might not get something that's helpful, though. Yeah. I guess you can't really isolate x or y, though, in these original ones, can you? Yeah. All right, so, Emiliano, I guess if you want to... It looks like your work kind of stops soon after this anyway, because you get something that's hard to work with. Do you want to maybe make those corrections and see if you're able to get through the problem then? Or is there something else that you want to ask me about? So you're in, try to make it? All right, sounds good. Thank you for the question, and let me know if you run into anything else. All right, so we might try to just do minority suspects question from scratch here. Oh wait, they deleted it. Okay. You'll upload again? Okay. Yeah, I was thinking it might just be because I'm sure cleaning up your work is going to take a lot of work, so I could just like try and work through it for myself too. But it's up to you. Oh, I know the image is still open here. Let me copy down the problem and see if we can work through it as well. Yeah, 45. 8 arcsin x over 4. Minus or 2. Okay. So I'll try and work through it for myself as well, and I'll try to use your same technique here. So you basically isolated the arcsin, which is fine. You add that to each side. Let me write it in the same order that you had it to, because you had the y first. Over 2 to 8 arcsin x over 4. Then you divided by 8 and took the sine of each side. So you got that sine of y over 8 plus x root 16 minus x squared over 16 equals x over 4. All right, so you got a common denominator there. I think I'm just going to leave that as y over 8. Maybe I'll come to regret that later, but let's just see how it goes. So what you did from here is you did the dy by dx of each side. Which I'd never done implicit differentiation when like there's a function of x and y's mixed together, but I think how you did it makes sense to me, which is you just write the sign as just a normal sign, so it becomes cosine of whatever was inside originally. Then chain rule, we have to derive the inside now. So that derives to y prime over 8. That derives, we need to do a product rule. It's going to be a little bit annoying. That x derives to 1, so we get root 16 minus x squared. That is going to be x times minus 2x over root 16 minus x squared. All over 16 is equal to 1/4, tiny over there, because the x over 4 derives to 1/4. Okay. So then cosine y over 8 plus x root. Oh, who's that? Milo, thank you for the follow. You ready for the Tech 9 lyrics? Wait. Tech 9? That's Snoop Dogg. Maybe Tech 9 is referencing Snoop Dogg. The derivative of the inside threw you off. The quotient rule with product. Like, that one is... You could do quotient rule, but it'll end up just being a product rule, I think. But like, you can derive that on its own, derive that on its own, and that's just a product rule. Unless I'm misinterpreting what you're asking. See, for the implicit differentiation of that, I think you did it right, but I never actually encountered that exact situation, so I'm just kind of going with it. And we can verify the answer at the end. What was I doing here? I was going to clean up that part. So I guess it's going to common denominator between these and these. X times negative 2x is minus 2x squared over 16 root 16 minus x squared. I think that's okay. Dude, this is so weird. Because we're going to get cosine of that thing. Oh, we're gonna get a cancellation. Okay, I guess it'll work out. To something that's clean. We need to verify this in Wolfram Alpha at the end. It's gonna be really... So I'm gonna divide by that cosine, I guess. Minus x squared minus 2x squared is minus 3x squared. 16 root 16 minus x squared. 1 over 4 cosine y over 8 plus x root 16 minus x squared over 16. Like that? Nothing new in chat. Also, hi, Tells. Hope you're good. Take 116 out and then do product. Oh, yes, yes. Because there is like a quotient there, but the 16 isn't a function, so I basically put the 16 out front, did product rule on the inside, then brought the 16 back in. Because it doesn't actually affect anything. It's like 16x, or, well, x would be a cancellation, but, you know, if there's like 16 ln x or something, you definitely need to do quotient rule. But when it's just 16 with no x's, just do a product rule. Quotient rule should be the same thing, though, I think. I'm not sure. So I divide each side by cosine. Let's subtract over this bit, multiply through by the 8. We're not done, but we do have y prime isolated. If you multiply through by 8, there's a 4 there, so we get a 2 on top. Now what I'm banking on is that this horrible looking thing is going to get simplified. I hope that's what's about to happen. So we're multiplying that by 8, so that's going to turn into a 2. Let's clean up that 3. Okay. Hey, Pitagia, I think. I always forget. I think I pronounce it a different way each time, but hope you're good. So we set it to a right triangle. Like from here, I would I want to unsub this y before I even think about a right triangle personally. I think that you've done them. You tend to do the right triangle like off the bat, which I guess you can do. I tend to not do it until I actually like need it, I guess. So we have to remember here that y is equal to that. So let's plug this thing in and hope for the best. So it is y over 8. That has an 8 in front, so I'm going to write just arcsine. Then that gets divided by 8, so it's this over 16. And it's going to be minus. So we do get a cancellation, thank God. And then we have that plus 16 minus x squared. Okay. Minus 16 minus 3x squared over 2 root 16 minus x squared. Okay. So those are going to add to 0, and you get just cosine of arcsine of x over 4, which at this point is when I personally do these problems. Now I draw a right triangle to simplify cosine of arcsine. So so I would normally do it as sine is opposite over hypotenuse, so I'd do like x in 4, but I think you did x over 4 in 1, which also works. I don't see like what's wrong with that. Which means the remaining side here is root 1 minus x squared over 16. Because it's all the same ratio, just scaled different. So I'd hope we get the same answer regardless. Yeah, I think we do. Okay. So that means y prime is going to be equal to 2 over cosine of this right triangle, which is just that. Minus 16 minus 3x squared over 2 root 16 minus x squared. Okay. Does that, like, we could probably do some trick here to make these get the same denominator. I think that's maybe what you were doing at some point in your work, if I was able to follow it better. Sierpinski's triangle? I never even heard of that. I'll have to look it up. Question to ask, then you answered it yourself? Oh, okay. Well, cool. Glad you got your answer. See, if you factor out a 1 over 16 from here, you'll get 16 minus x squared. And it gets square rooted on the way out. So 2 over 1/4 times 16 minus x squared. 16 minus 3x squared over 2, 16 minus x squared. Fraction over a fraction, you can bring it up, so that'll be 8, and then you need to get a common denominator. So it's going to be 16 over 2 root 16 minus x squared denominators match, so I'll do in separate steps, so I'm not doing too many steps at once. We've already gotten the answer once we get to like this point, but I'm just doing some simplifications. So 16 minus 16 is 0, minus negative 3 is positive 3, x squared over 2 root 16 minus x squared. Okay, hopefully that's the answer. Let's check it in Wolfram. It's like a triforce infinitely tessellated. Oh, okay. um, 8 arcsin x over 4 minus x square root 16 minus x squared. They're on your model? Really? I'll have to look the next time I watch your stream. X squared. No! I have a 3 over 2. I messed up. I have nearly the right answer. Just the 3 over 2 is off. Oh, man. Oh, yeah. Peta. So I thought we should have gotten a 3 in the denominator, or we should never have that 3x squared there in the first place. So, I mean, this doesn't mean your process is right. I just made some arithmetic error at some point in this work. I'm trying to find it. Where's the theta space instead of x space? Oh, really? Like doing x equals r cosine theta? Actually, well, no. It's theta space another word for polar? Create some version of polar that works for like this situation. I think that's how minority is supposed to do it, but that is an interesting like thought. And this is a technique for getting the derivative. Isn't even what I do normally. I just would use the formula for the derivative of arcsine. 8 theta equals 8 sine theta cosine theta? Or 8 theta minus... Oh, wait, never mind. That's not an equal sign. That's a minus. Huh. Also, that's basically just a change of variables. You're taking theta equals arcsine x over 4 and realizing that the second term it can be put in terms of that same thing pretty simply. That's a neat way of doing it. But I don't imagine my minority is supposed to use a change of variables like that. Gotta run? Oh, shoot. All right. I'll put my work up in the Discord, or I'll keep it up on the board and see if I can spot the arithmetic mistake that I made. And I'll post it in my Discord if I can find it. So let's, I guess we can do this drawing. So the infinite triforce, basically. Very natural for a trig sub, yeah. Zach. Thank you very much. Yeah, you know, just for you, I thought I'd bring up a fractal. Hope the rest of your stream was good though. We have a redeem from Talos to draw this Sierpinski triangle. So I was just looking at an example of it. An accent over the N. I've never seen that before. I know what that means for the pronunciation. You love that drawing challenge? Yeah, so I don't know. I mean, I think we're gonna make use of ... here or something, because my whiteboard is only finitely big, unfortunately. Your favorite? You have a tattoo of it? Wow. It's crazy. It's a good estimate. I mean, yeah, if it's getting, I can make it infinitely small rather than infinitely big, I guess. And then it's like, ooh, some squiggles. It's an infinite triforce, yeah. All right, well. I'll do it there. So equilateral triangle. It's equilateral-ish. Then we make the triforce. Wow, that does not look even slightly okay, but who cares? Now we make triforces out of each of these three, right? It's like one of those Facebook how many triangles are in this picture questions. And then out of all three of these, we make more triforces. Okay, and out of these, we make more triforces. Infinite time later. And this is the good part about making them smaller rather than going out bigger, which is, you know, after about this point, I'm just going to make some squiggles and say that those are the continuation triangles, and if you can't see that, then check your eyes. So, you know, I mean, obviously, you know, we're going to get even smaller in here. Blah, 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 blah. See, I start off strong, and then I start phoning it in and getting lazy. That's how I do everything. Am I doing... Missed one? Wait, it had 0 area and infinite parameter? Grab my infinitesimally thin marker? Yeah. Hey, Felix. Oh, wait. And Brian, did I say hi? If I didn't, then hi. Sorry about that. I missed one? Oh, I missed that one. Okay. There. Happy now, Jed? Squiggle. I mean, it's not even that squiggly. Blit, blit, blit. Do 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 do. Dude, I don't know. Black. I've completely devolved into just dots. You know, prove to me that those aren't just dots. Okay. There you go. Perfect Sierpinski triangle. Put it on the Wikipedia page. Send it. All right, see you, Brian. Thanks for coming along on the raid. Center me, I'll try and pick a random vertex, go halfway, plot a point. Can you code this? Director reading is all about fractals. Oh, cool. I mean, I probably could code it if I really wanted to. I've done very little like visual coding stuff though. So I've got ways up to n equals 2. I guess so. Merging, we take a random point, walk half the distance to one randomly selected corner. I guess that accomplishes the same thing, yeah? Hey, Sharath Chandra on YouTube. Can you help me learn about a graph's maximum and minimum? That's why Gannon keeps losing. Yeah, so what about a graph's minimum and maximum? Like, are you in a calculus class? Are you just looking at the graph of a function, or like, do you have an example question that I can maybe talk about? Actually, in Wind Waker, the one that I played as a kid, the Triforce was like broken up into pieces. Was it broken up into like smaller triangles? Also Trifarce. Dude, it's like the worst part of the game too, having to go to all those stupid treasure chests around the map and just get all the pieces. Gemina curves. Want to learn this from machine learning basics? It's not gonna show it to me. By the way, if you want to post a question, please do. Well, yeah, so Sharath, I need some kind of example problem where it's like you post a specific example that you would want to see done. Because there's a few different interpretations here. I'm not sure which one is relevant to you. What? Why can't I X that out? Thank you. Hey Milo, can you explain how to use and when to use wire stress substitution? Wire stress? I never actually done that before. I feel like Pen Center has just been playing around with that on his 100 integral streams, so he might know a bit about it. Oh wait, no, I know wire stress. Oh wait, yeah, that's with sines, right? Maybe I do remember these. It's these. I barely had to use them though. So yeah, Milo, it's when you have a weird trig integral that doesn't have a clear way to integrate it. Like, you can't do a normal, like, there's no identities that we can use in a situation like this, like 1 over 1 plus sine x. So you use a wire stress sub in a situation like that, where you can't find a way to clean this up or get in a different form with identities, or a U sub or something. Or, I mean, the wire stress sub is basically a U sub, but a more conventional U sub, I guess. Okay. Thank you very much, Sharath. And Bio, I'll look at... Ooh, that'll be a fun question too, but Sharath asked first. So let me work on their question, and then I'll get to yours, Bio. All right. And thank you for bearing with me. Sure. I just didn't want to explain the wrong thing to you and have it be completely useless to you. I made some mistake here that's going to bug me, but I don't have time to try and fix it now, so. Okay. So Shara, you have. Yeah, so Max probably is saying the idea here. And I'll show you what that means. Y is equal to 2x cubed plus 3x squared minus 12x plus 5. And you want to find the local maxima, global maxima, and likewise for the minima, and probably if it's a critical point, but neither minimum or maximum. So first off, we want to take the derivative of this. So y prime. You take the derivative of this by, you can do it each term individually, and we lose something called the power rule. When you have just x to a power, what you do is you bring the exponent down and you multiply by it, and you subtract 1 from what it was. So that 2 stays there, the 3 comes down to get multiplied. So 2 times 3 times x. Now instead of cubed, we have squared. So you subtract 1 from the exponent. Similarly for this one now, the exponent comes down, so it's 3 times 2 times x. 2 minus 1 is 1, so x to the 1 or just x. Now we get minus 12. Now that's x to the 1. So the 1 can come down and get multiplied, but 1 times anything doesn't change it. And then 1 minus 1 is 0. So you get basically x to the 0, which is just 1. So really, you just get the minus 12. And then 5 is a constant. Constant's derived to 0, so we don't get anything else for our derivative. Yeah, so sorry I couldn't give you a better answer, Milo, because I've only barely done those subs. If you have a specific question, I can try and work through it. For like a specific question that requires a virus trash sub, I bet I can figure it out. But in general, use it when really you have no other option with an integral involving trig. All right, so I'm going to clean this up a little bit. 2 times 3 is 6. 3 times 2 is also 6, minus 12. All right, so now we want to find the critical points, and the critical points are wherever the derivative equals 0. So we're going to take our derivative, set it equal to 0, and solve that for x. So I'm going to divide everything through by 6 to make the numbers nicer. So divide each side by 6, you get this. X squared plus x minus 2 equals 0. Now we can factor this as x plus 2 times x minus 1 equals 0. That means we get x plus 2 equals 0, x minus 1 equals 0. So x equals negative 2, x equals positive 1. So we have two critical points, but we don't necessarily know if they're minima, maxima, or neither yet. Oops. So now we want to do something called classifying. And in order to classify them, we need y double prime. So let's take, I guess, this and derive it again. So 6x squared, we do our same power rule. The 2 comes down, you get 12x to the 1, so just 12x. 6x derives to just 6. And then the minus 12 is a constant, so it goes away. What is my bench max? Hell if I know. I haven't bench pressed anything in years, and even I didn't try to go for a max. Probably something very low. All right, so we have our second derivative here, and we need to take the critical points we found from before and plug them in. So y double prime of -2 is 12 times -2 plus 6. So that's -24 plus 6 is -18. The second derivative being negative means the function is concave down. So at some point it looks something vaguely like that. That's what concave down means, which means at the top there is a maximum. So we'd say y equals -2 is a local max. -18 is less than 0. So x equals -2 is a local maximum. Now let's do the same, but for x equals +1. 12 times 1 plus 6 equals +18. So now we get +18 is greater than 0, which means it's concave up. The graph is vaguely shaped something like that, and at the bottom there is the minimum. So x equals 1 is a local min. Now the only other piece, if you get equal to 0, we'd say it's neither maximum nor a minimum. Here we don't have that though. Okay, so now the other piece is the global minima and maxima, and for this, you kind of have to think about the entire function. So a cubic function with a positive leading coefficient looks something generally like this. You can even be a bit more exact, because we know that -2 is a maximum and +1 is a minimum. So this isn't drawn to scale, but just like something vaguely like this. And since the function goes up to infinity over here and goes down to -infinity over here, we don't really have a global minimum or a maximum, since the function just increases without bound and decreases without bound. So depending on the context, you might say the maximum is infinity, the minimum is -infinity, or maybe say you don't have one. But you certainly have a local max at -2 and a local min at +1. So I think that's kind of everything you can say about this. Let me know if there's a piece that I missed or the piece you have a question on. Following? Okay, good. I don't remember what part, I don't know what part you said that exactly, but I'm glad you were following me at least a good part of the way there. Where there will exist a global min or max. Yeah, sure. Don't know if you were gonna... Yeah, bio. I literally tell you I don't want... I'll answer your math questions. I'm not gonna answer your weird-ass other questions. So I would say a case where we do have a global minimum or maximum. The easiest case to think of is probably a polynomial with an even power, like a parabola. So let's take y equals, I don't know, x squared plus 2x plus 1. So this is a parabola facing up. But I guess before we get into, let's do the same procedure here and figure out what the critical points are, and then we'll come back to the global min or max point at the end. So let's get our y prime. 2x plus 2, set it equal to 0. We get x equals -1 as our only critical point. Let's get our y double prime. We just get 2, because 2x derives to 2, and that 2 derives to 0. So that means the function is always concave up. So shape something vaguely like that. In the critical point here, there's no x, so there's no other thing to plug into, but it's always concave up. So we know this one critical point will be a minimum right there. So this way, we can definitely say that x equals -1 is a local minimum. But we can say it's actually also a global minimum because this is a parabola, I guess at x equals -1. We're going to say this is a global minimum because the parabola never is going to dip below there. So you kind of have to think about the end behavior of the function, it's sometimes called. It's not always like as it goes out to the left and right, but often you have to like think about, you know, for very large values of x and very small values of x, you kind of have to check if whatever just increases infinitely rather than like having a horizontal asymptote and leveling off. But in this case, we definitely never go below the 0 point at x equals -1, so we'd say it's a global minimum. Hope that makes sense. That was not dating advice you were asking for, dude. I'm not. Hey, Cosmic Voyager, welcome in. How's it going? Awesome. Glad I was able to help you, Sharath. Yeah, for like the globals, in my opinion, we really should just like graph it to be sure that you're talking about the global correctly. Pound of photons or a pound of bricks? Well, I would say they weigh the same if it's a pound of each, but do photons, I guess they have, wait, photons, like, don't they sometimes have mass depending on how you think about them? A pound of bricks? Felix, it's not. Oh, it is happening. Bricks are heavier than photons. That's pretty cool. Oh wait, okay, so we got a couple of questions from chat. So we have to come back to Emiliano. Oh shoot. We have a question from Timo. And we have a question from Bio. So to people who are watching, I have a couple questions to juggle here, so please bear with me. I think Bio was the first one. Have it playing in the background? Yeah. I really should. And Felix, that's cool. Thanks for making it. So Bio, let me copy paste the question again. Or actually, Stooky, did you just get the answer? Because that'd be convenient for me at least. What is S equal? Okay, no, it's not, maybe it's not resolved yet. So relatively few science channels? Yeah, I mean, Cosmic in general, if you're interested in math, a lot of often streaming the math category. I've been trying out the science category just to see if people come by, but there's quite a few math streamers out there. If you ever are interested. Interested in physics in particular. There's also physics in depression too. But yeah, there's definitely not a ton of us, but we are out there. So binomial. That's someone want to watch Matthew. I know it's crazy. In binomial root 3 plus 1 over root 3 to the n, the relationship between the third and fourth member is 9 to 10. What's the sum of the binomial coefficients? Three body problem series on Netflix. I didn't know they were. I don't know. I knew that was a joke. I don't actually have a Netflix account anymore. It kind of got to be not worth it. I didn't know they're coming out with that either. Don't watch math in your free time from Matthew. What's the sum of the binomial coefficients? In the binomial root 3 plus 1 over root 3 to the n. It's 9 to 10. So we need to get our binomial theorem out. So, okay, once I do a BIOS question, just to let people know, I'll go to Emiliano, and then I'll get to Timo. So I'm sorry that I have to, like, juggle a couple of different people here, but I'm just doing the best that I can. So third and fourth terms, I guess it's the infinite expansion? Like, make a Chinese series based on knowledge about science, philosophy, and math. Oh, okay. Or is it just, if you have like the third and fourth terms, what is the total? Or maybe it doesn't matter, like the third and fourth terms, no? I'm so bad at the binomial theorem. I haven't done enough problems with it. Maybe the ends are going to go away at some point? Let me see what was happening before. T3 and T4, you're going to equation with n. Okay, yeah. That makes sense. Aliens send a video game to Earth to see if humans can solve three-body problems to save their planet. Oh, that's interesting. Okay, so we have root 3 plus 1 over root 3 to the n. It's called the chaos game. Okay, nice. We cancel Einstein end of series. Okay, so by the binomial theorem, the third term is going to be n choose 2, because you start from k equals 0, times root 3 to the n minus k, 1 over root 3 to the k. And 9 times that is equal to 10 times the fourth term, which is k equals 3. And then we want to use the factorial formula for the combinations. There's a famous Erdos quote about aliens in the Ramsey number. I feel like we've talked about that before, but I don't remember it. 9, wait, so what's n factorial? 2 factorial, n minus 2 factorial. Someone's honking their horn. Can we make some, do we get a cancellation here? That's root 3 to the negative 2. You add their powers. You get just root 3 to the n? No, n minus 4. Because that's negative 2. So negative 2 plus negative 2 is negative 4. Okay. N minus 6, right? If aliens starting to destroy Earth once we found the 5th Ramsey number, we should gather all mathematicians and work really hard on it. If they ask for the 6th Ramsey number, we are doomed. So I guess we can solve this. Maybe we can solve this for n? I don't even know. Oh wait, we just need the sum of their coefficients. Why am I guess we need to figure out the coefficients. Wait, was the ratio of the terms or the coefficients? I'll copy paste it from the YouTube chat. Apparently that's a quote from Erdos, however you pronounce it. The 3rd and 4th member, okay. Get n, apply formula to s equals 2n, and you get the sum. Don't know how that's going to work. I'm still trying to work out the constants here. N minus 6 minus n minus 4 becomes the negative 2. So yeah, we can solve this for n. Okay. 6 over 2 is just 3. Times 3. Is that it? That doesn't feel right, does it? It's an approximation of the quote with some grammatical error in the mix, to be precise. I don't know what your apply formula with s equals 2 to the n? S equals 2 to the n? What is s? Like, don't we just... The sum of the coefficients, don't we just do, like... I mean, I guess we had a common denominator there, but... Oh, we're gonna have a fraction involved, aren't we? What is 3 times 81? 243 over 81 equals 253 over 81. Not divisible by 3, so I don't know how much we can do there. So I thought the answer would just be like... Oops. If n is this, then it's that, choose 3, plus that, choose 2. But That's a fraction. So that's like, that can't be right. Unless you want to get into the gamma. Um, yeah, but I don't know what you're saying for this next part. I feel like I shouldn't have gotten a value like that for n. But I don't know what else to do. Um, the answer, yeah, basically, Jeff, and then they need the answer in the format of the sum of the coefficients. Two to the n, sum of binomial coefficients. Really? Oh wait, of all the coefficients. I thought it was just the third and fourth. Maybe I didn't read the question carefully enough. Oh, it's the sum of binomial. Oh, okay. Not just the third and fourth, but in total. So I guess the sum maybe doesn't care about a fraction being involved. So yeah, you do 2 to the power of 253 over 81, and I guess that's your answer? N equals 12? Oh, well, I did something wrong then, if n equals 12. You just don't get how. Sum is 4096. Okay, yeah, so I did something wrong. N minus 1 over 2 times 3 to the n over... What? Oh, okay. That's what I was thinking, Jeff. So we want k equals 2 and k equals 3 for the third and fourth terms? Yeah. Or like the coefficients, yes. But the question was the ratio of the terms. Or it says the ratio of the terms are 9 to 10. So it's both the coefficient and the factors, I guess. As far as the ratio is concerned. Just add the binomial coefficients. 12 to 0, 12 choose 1. Do you know that without having solved the problem first, though? That it's n equals 12? Yeah, so we still need to get that 12 somehow, is what I'm saying. And I think Jeff and I are doing basically the same thing. I don't know why I didn't get the right answer. Did I make an algebra mistake somewhere? I did. N minus 3 is less than... Oh, I didn't mean to do that. Wrong hotkey. And that hotkey isn't even working? Okay, well, I have to fix that. I multiplied both sides by n minus 3 factorial, and I said that n minus 3 factorial over n minus 2 factorial is n minus 3. That's not true. N minus 2 on the bottom. Does that get the right answer now? Okay. 3 factorial over 2 factorial is 3. 3 times 9 is 27. (27 times 3 is 81. We still get this 81 over 10 business. Or 10 over 81, or like a really weird thing. Flip each side, multiply by 27. Will it happen to work out if we get a common denominator here, though? Nope, that's not 12. That's also not how you do math. So I made another mistake somewhere? Shouldn't surprise me. What's wrong with this, though? Did I do that exponent math right? N minus 6 minus, in parentheses, n minus 4. I think it's just root 3 to negative 2. Do I have the ratio reversed? Like, should be 10 times that equals 9 times that? (28 over 9? I mean, it should be 12. Yeah, I mean, that's basically what I have. Well, kind of. Like, n over 2 is the same as root 3 to the n. Like, you could rewrite, like that. Like that. I think it's what your teacher did. I don't know why they have a 2 instead of a 1 there. Maybe because of that. The ratios were reversed? Oh, really? Okay. Let me try it. Let me reverse the ratio then. I was about to go back and reread the original wording, but I'm just going to take your word for it. Okay. So that's going to be 30 over n minus 2 equals 9 over 3 is 3. Flip each side. Multiply by 30. Oh my god. That's not right. So this is not a fraction. No, 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 no. 1/3 times 30 is 10. That's 12. Okay. So I don't need to try to do too much mental math. Okay. You want to learn to block transfer mathematics. You needed to build... Really? I never heard of block transfer mathematics. I don't really get how you did it. That's fair enough, Bio. So now that I actually know that I set it up right, I'll try and re-explain it, and then I do have to get to Emiliano and Timo. So they've been waiting for a minute. If they already had to leave, I'll go back to them on Discord. So Bio, do you? It sounds like maybe you don't understand the setup. Let me actually go back to the wording. Do I still have it copy pasted? No, I don't. Of course. Scroll up. The relationship between the third and the fourth member is 9 to 10. 3/4 is equal to 9/10. Okay, so I did have it flipped. Okay. Block transfer computation can create objects in effect space-time through the power of pure math. Oh. Involved chanting. Okay. So instead of being our approach kind of math with factorial and stuff. Okay, so I did kind of glaze over that. So if you're good with the setup, I'll go with the factorial math and kind of break it out a bit. Okay, so if you're good with that and you're good with that, let's go into how I got the cancellations like between these two steps, because I definitely glazed over that. Just erase that and go back through it. So the first thing I did, that I divided each side by n factorial, which I think you'll be good with, because n factorial over n factorial on each side, just get rid of those entirely. All right. Next, I multiplied each side. I don't want to do this all at once. Let's multiply each side through by n-3 factorial. Because that's kind of the hard part to understand here. So those n-3 factorials cancel. 10 n-3 factorial over n-2 factorial. 3 to the n-4 equals... Okay, so simplifying n-3 factorial over n-2 factorial is a little bit weird if you haven't seen it before. You have to remember what a factorial actually means. So n-3 factorial, let me just rewrite the original thing. On top, n-3 factorial is the same thing as n-3 times n-4. n-5, all the way down to 1. n-2 factorial is nearly the same, but we start with n-2, then n-3, then n-4, n-5, 1. And what happens is this n-3 cancels that n-3, that n-4 cancels that n-4. It cancels all the way down the line, and all you're left with is the n-2 on the bottom. So that's how you deal with factorials. So 10 over 2 factorial n-2 root 3 to the n-4 equals 9 over 3 factorial root 3 n-6. So does that like make sense to you? That's fine so far? Okay. So that, I think that's the hardest part. Let's keep going through the problem though. I'll divide each side by the root 3 to the n minus 4. You have division by the same base, so you subtract the exponents. So you have n minus 6 minus n minus 4. So n minus n is 0. N minus n is 0. Minus 6 plus 4 is negative 2. So you end up over here with the root 3 to the negative 2. Okay. Now, I'm doing a slightly different order than I did it initially, which might be for the worse here, but we can, I've been writing that as 2 factorial and 3 factorial, but 2 factorial and 3 factorial are pretty easy to calculate, so let's just do that. 2 factorial is 2 times 1, which is 2. Oops. 3 factorial is 3 times 2 times 1, which is 6. Come back up here. So we can instead write it as 10 over 2 n minus 2 equals 9 over 6. And I'm going to say that root 3 to the negative 2 is 1/3 because you're squaring a square root and flipping it. And now we can simplify this and solve for n from here. The 10 and the 2 cancel to be 5 over n minus 2. 9 over 6 is 3 over 2. 3 over 2 times 1/3 is 1/2. Now we flip each side. Multiply through by 5. Add 2 to each side and then get 12. All right, so I hope you're good with that, Bio. Oh shoot, maybe I shouldn't cover that up. So I think the most difficult part was that part in red. All right, sounds good, Bio. All right, so let's go to Emiliano and then Timo. Sorry to keep you both waiting. So if you're not still here, I understand, and I'll get back to you on Discord. So Emiliano, let me bring up the work that we had before here too. So that had to be a y squared and that had to be an x squared. You are here. Okay. You made a mistake and you're correcting it? Oh, okay. I was gonna say, this looks like a bit of a mess. It might be right, but I don't know. If you want to... Okay, yeah, sure. I'll go to the other one first. Thanks for letting me know. Okay, so Timo. Is this Dutch? That's my guess. It's not really, I guess it's not really important. I think it says show the function is continuous at 0, 0. I should probably get this into Google Translate. Oh, you're here. All right. Thank you for waiting. Sorry about that. Yeah, so you said yes, show the function is continuous at 0, 0. Okay. So we can definitely do this. So to show that this function is continuous, we have to show the value of the function is equal to the limit as it approaches that point. So let me erase this. Okay. So we have f of xy. Also, welcome in team if I didn't say that. Thank you for asking a question in the first place. X cubed minus x squared y over x squared plus y to the 6. When x y is not equal to 0, 0. It's equal to 0 when x, y is equal to 0, 0. Okay. Okay. Oh wait, I wrote that wrong. Wasn't that to the 6? Yeah, okay. Okay, cool. So what we need to do, we want to show that the limit as x, y approaches 0, 0 of f of x, y is equal to 0. So we have to evaluate the limit of this function as it approaches 0, 0, which means we need to do this. Basically, we need to do as x, y approaches 0, 0 of x cubed minus x squared y over x squared plus y to the 6. And we need to hope this comes out to be 0. And how do we do that? How do we show limit does exist when we can't plug it in? Because I don't see a convenient cancellation. You know what? I might show a little bit rusty on this. I may need to go to Google here. But I realize I'm more used to showing they don't exist, and I don't remember a good technique to show they do exist. I can't look at that quite yet, Felix. I want to get through this question, and then I'll take a look. Evaluating multivariable discontinuity. Oh gosh. This book does epsilon delta. I don't think that's what we're supposed to do here. I mean, maybe it is, but... So, I mean, we could do that same substitution with y equals mx. It's not actually proving the limit, though. When you prove the approaching for different paths, the values are the same. Yeah, it's just like there's a very formal way to do it that I don't think is what I don't imagine is what you have to do. Like using this epsilon delta like proof way. um Oh, could we separate the x's and y's? That's what they did here. But the denominator, you can't really separate that. Hmm. Yeah, I mean, maybe we just take y equals mx. Like, it's not an actual proof, which is why I'm, like, a little concerned. The inverse function of x squared. So x squared actually has two inverse functions. It's root x and negative root x. And which one you want depends on the situation. X squared plus y squared is greater than x squared. Doing greater than that? Like maybe trying to do squeeze theorem? I mean, that could be it. You think you didn't understand? So I'll just take a quick thing to try and explain it. And then I'll go back to Timo's question. So y equals x squared is actually two inverse functions. It's square root of x and minus square root of x. And that's, we have two separate functions for it because if you've ever heard of the vertical line rule, this function kind of like violates it. So we say like there's the upper half of this sideways parabola and the lower half, and which one you want depends on your situation. Nope? Okay. You want to make -2 go with 4 with -2 squared. So for your inverse, if you want to plug in 4 and get -2, you want y equals negative root x. So if you want a negative result, you have to stick this negative sign in front. Is the answer to your question, basically. Like you want that bottom half of the parabola. If you want to be able to make 4 go with -2, then that's your inverse there. There's another situation you might want that as your inverse, but for what you said, you want that one. So yeah, Timo, what you said, but I guess let's try it and see where it goes. I'm not, it's been a long time since I've done a problem like this in particular. No worries, Oveja, glad to help. Because showing a multivariable limit does exist is not easy. Let's just see what happens with that. Because we expect to get 0 for the overall limit, so we might get some kind of nice thing out of this. So let's try the thing that you said and say that this, I guess we'd say less than or equal to xy approaches 0, 0. X cubed minus x squared y over x squared. And we can also say that it's less than or equal to 0 on this side. So we don't expect it to be exactly equal to 0. Can it be negative? The denominator is always positive. The numerator, it's possible for that to be negative. I don't know about that left side. Let's just try evaluating this limit and see what happens, though. I'm a little bit unclear, though. So we can cancel out the x's, I guess, and we get x minus y, which is just 0. So we've bounded it above by 0. Can we bound it below by 0? Like, could we say, I'm just kind of guessing here, but like we could put an x squared in front of it or something? Would that do anything for us? No, we still get 0 over 0, don't we? So maybe that's not how we want to modify it. Numerator is always positive? As long as the right one is 0, you should use absolute? Oh. I guess if it doesn't matter, I mean, what was I thinking? Well, I mean, okay, I guess if we're just say able to use 0 here, then I guess we're done. I guess we've done the squeeze theorem. If we can say the numerator is always positive, I'm not sure exactly. Like, if y is greater than x, they are both approaching 0, but... Huh. I'm not sure. I'm a little bit... I haven't done this in a while, so I'm not that confident on it. I think your idea with the bounding from above is good. It's that 0 part, like, it certainly fits. I can't, like, promise you that that's right. The other paths that do not go to 0. Right, so that's the part that I'm even less certain of. No worries, Jeff, you're good. Like, we'd have to prove those don't exist, and that's, Actually, no, if we squeezed it, I think that takes care of the path. Like, if this squeeze holds, I think it's okay, regardless of path. They don't actually prove it. Oh, that's lazy. Okay. That's probably not lazy, but... Oh, wait. Maybe they do an actual similar one here. Hmm. Okay, well, fine. So I'm not sure. I think that might be enough to show it's continuous there. I'm not that confident in this, though, I guess. What's part B, I guess? Argue that f is continuous in the whole R2. To x minus y in the original function. And we know it's 0 and it comes out to 0. Like, so to x minus y equals... could try that. So like, I guess we get an x minus y up on the numerator? So if that's 0, I just don't know that that isn't 0. I guess we can show it's not. Or I guess if that is 0, that can't be 0. Because that can never be 0 if that is 0. So I guess it comes out to be 0. Use L'Hopital for multivariable limit? That might be possible. I don't know how, though. Yeah, no problem, Timo. I can't answer you more confidently. I'm glad I was able to help you a little bit. Do you need help with like B and C as well? For B, I'm not quite sure, but for C, like the partials, like, I guess I could get. Continues for the whole second dimension. That's what we did in 0, 0. I guess showing it's like continuous outside of 0, 0, I guess. Okay. C is the hardest. You would like help with that one. Okay. So just give me the partial in terms of x and partial in terms of y? Wait, in 0, 0. That actually might be harder than I thought. Can we use... I was thinking we just use the upper function here and get the partial in terms of x and y. But they do say in 0, 0, which maybe means something more that I'm not aware of. So I do have to show that the whatever partial we get holds for that 0, 0 point. There are no weird points next to 0, 0, so it's continuous in the whole second dimension. Oh, okay. And you have the same question as me for that in 0, 0 point. Okay. Let's do a bit more Googling, I guess. You got the derivatives easily. Why don't you plug 0, 0 in for them? Do you get a... Like, are they continuous there? Then you get 0 over 0. Okay. So I assume you need to maybe manually define the partial derivatives to what they should be. And how could we do that? You have to do like local there. Yeah, no, maybe does locals exist for multivariable? If it does, I never learned about it. Yeah, so you can only use locals for single variables. So you'd have to do some kind of like you can take it along a path. Oh wait, there's a sort. Maybe huh? Maybe it does exist. Um. Okay, so this might be a thing, but I think you have to take the limit of the partials as they go to 0, 0. I think what they want you to do is define the partials at that discontinuity. So I think the partial terms of x take the limit as it goes to 0, 0. Partial terms of y as it goes to 0, 0. Polar coordinates could work too. Well, that bottom is going to be messy. It could work. But no, I feel like they do want you to create a function for the partial that fills in that discontinuity there. Like find what value of the partial makes sense at 0, 0. You'll send them over? Oh yeah, please do. Ooh. Viter Weber? However you pronounce that? Thank you for the follow. See, looks like you sent them. You're good. It looks like they might not be fully simplified. Let me actually just get the partials anyway, so I can try and play around with them and simplify them a bit. Because I think we're gonna have to do the limit as they go to 0, 0. I feel like that's what the question wants. So the partial in terms of x, derive the numerator first. 3x squared minus 2xy. Minus the original numerator times the partial of the denominator over original denominator squared. Ah, dude, I keep writing that. I feel like it should be y squared. It's y to the 6th though. You know, you don't really get that convenient of a cancellation, do you? I don't think we get any other. Oh wait, those go away. Bam, bam. Oops, not that. Okay. Anything else we can do with this? Factor an x out, that doesn't do too much. Oh, you know what? There actually is. If we split this up a bit, that doesn't really help though. Never mind. I think we need, so if this is our partial in terms of x, I think we do the limit of that as it goes to 0, 0. I think they, like, this isn't defined at 0, 0, so we need to create a definition for it, I think is what the problem wants you to do. Like, you have to make it continuous. In the same way we proved that this one was continuous, we need to do the limit of this and say that the function is equal to that thing at that point. And it's equal to something that we need to fill in for xy does equal 0, 0. I think we need to fill that part in there, and that's what the question is, I think. So we need to do the limit as xy approaches 0, 0 of the partial That's not exactly easy. I'm gonna hope that it's also 0 like that one was, but what can we do here? Y equals 0? Can we? Get us the correct value, assuming, assuming it's continuous, yeah. So yeah, you're right. We could just try and figure out what the limit should be if it's going to be continuous. Oh, yeah, yeah. Okay. I think I like that. It's probably not like that rigorous of a proof still, But I think that's a good step. 0 and 0 over x to the 4th. So that's just 1. Really? So we get 1. Do we do the same thing if we let x be 0? I feel like we should check that. That's not good. Oh wait, that just doesn't... Ooh. That's not good. Why don't we get the same thing? I feel like we shouldn't cancel these if x... I guess x isn't exactly 0. It's like, I guess we expect it to be 1, but if the limit doesn't exist, that's kind of a problem. If we did the limit, if we let x equals y, just to do that experiment. X squared plus x to the 6. Oh. Squared. Well, that's just not pretty. Huh. Let x be 0 for the y derivative? Up to 1, it's probably 1. Yeah, I don't want to plug into Wolfram to see, but I think that's like kind of what you're supposed to do. I might be interpreting something wrong, but I think that's something like what you're supposed to do. I don't know why I'm getting different values though, doing things that I'm doing something wrong. X equals y to the 1/3. Oh, that seems like it's going to be a huge mess. I want to see what Wolfram Alpha does with this limit, I guess. With only x to the 4? Really? Wolfram says it doesn't exist? That's not good. In complex space. Wolfram might be doing something weird. X equals y to the 1/3. You're gonna get like... Alright. I'll trust you on this. It's logical that it doesn't exist? It is? Then what do we... Then I don't know what the question is asking. Like, I don't know what we put there if it doesn't exist. So, does this really... Like, that seems terrible. going to be 20 over 3. That's going to be 22 over 3. See, I don't know what you do with that. Oh, y with x to the 1/3. Okay, I was... But is this important? I guess I'm not sure. You have to pick something that it does not exist. Well, the limit should exist. I think the limit should always be the same. Because the function itself isn't defined, like... I don't know. So it was x to the 1/3? X, 4x to the 4th. That diverges, I think. No? Actually, no, it goes to 1. I think. Yeah, maybe it's just the partials. No, it does not go to 1. I think it diverges. But anyway, I don't think it's important. It might just be getting the partials. It's... If you do L'Hopital's on that, you get something weird, I think. Because the fractional exponent makes it harder. Because it's because of the 10/3 exponent. If it was a whole number and that was just a polynomial over a polynomial, I think it would converge to 1. But I think because of the 10/3 there, it's going to diverge. Yeah. If that was like x squared or something, it would definitely be 1. But not with the 10/3. 17 over 3? Oh, I mean, that would still diverge too, I think. So... 17 over 3? Oh, it is 1. I don't know how that works, but I'll go with it, I guess. Oh, I see why. Yeah. You split up into two different fractions. The one on the right will go to 0. The one on the left will be 1. Okay. Okay, that part makes sense, but I'm not sure what to tell you about this question in general, though. Like, you could... If you had to put an answer down, I would... Yeah, I guess just do the derivatives. Yeah, I agree with that. Sorry, I can't like tell you with more certainty what you're supposed to do. I feel like it is what I was saying, but it doesn't seem to work out quite right. So I don't know. So I could verify my partial, but I'm pretty sure I did that partial right. Helped you luck, got things clear in your head? Oh, hey, well, I'm glad I at least helped you out a bit. Got the same partial? Okay, just want to make sure. Because I didn't think we did anything wrong, but with that part. Yeah. Oh well. I guess that's the best that I can do for you. Glad I was able to help a little bit. And good luck when you ask your professor. It sounds like Emiliano figured out the answer to their question. Okay. Almost 1 a.m. Oh yeah, please go to bed. Thank you very much for the question and for being patient as I was working through other people's questions first. Hope you have a good night. Awesome. Thank you for subbing. I need to get alerts for YouTube. Okay, so I don't think I have any other questions from chat. It's been an eventful stream so far. I'm glad that we've had so many people coming in asking questions. You know, rather than looking for questions on the internet, we do have some outstanding things we could do for real analysis. And I think I'd rather do that than looking for questions. Because I skipped over, like we got through all the prompts for today, but I skipped over reviewing some of the ones from last class that I want to get back to now. So let me bring it up. All right, so this is from, today's Thursday, so this is from Tuesday. We got all the way down, we did 4, and so there's still 5 that we never talked about. So let's see if we can figure out 5. Use the uniform partition for meeting 18 for your proof. You may need a few sums along the way. This is a rather long computation. Oh, to get all... It's going to be a bunch of computation just to get to that simple thing. Maybe I should do the parabola one first. Because I didn't even really do the linear one. But I might just call it good on, like, close enough on the, It's like, I think last time I streamed math, I was working on 2. I did the lower sum. I think I eventually got it right. And the point is that the upper sum is going to equal the lower sum, and I don't really want to do the calculations all over again, at least not right now, just to find it'll be the same thing. So maybe let's go on to 3. Do we have anything else? Okay, no. So 3 is the only thing that we didn't do off this sheet, I think. So repeat prompt 1 for the function nu of x, let's say v, and first let's say v, and then let's say eta, and then I remembered, no, it's nu. Nu of x equal to x squared. You may bypass smaller n values if you desire. So I think we are going to bypass n equals 6. We can do it with n equals 12. I might set up a summon Wolfram Alpha to do it for me, though. Oh, do we use the same bounds? I feel like it'd be better if we did arbitrary bounds. Maybe arbitrary bounds is going to make it a lot more intensive, though. So, actually, let me clear out this message in my Discord. Okay, sorry, I had like a ping that I just wanted to get rid of there. So actually, if we do it for arbitrary bounds, we do have a bit of an issue with calculating the infimum and supremum. Because for positive x, the supremum is on the right side of each subinterval. And for negative x, the supremum is on the left side of each subinterval. Now, I was about to say we could simplify things and use the symmetry of a parabola, and maybe we still can do that. Yeah, we could only consider positive x and like create a procedure for if you have a negative bound. Because we know the area from -1 to 0 is equal to the area from 0 to 1. Well, I can claim that. We haven't proved it. No, I shouldn't do something we haven't proved. Okay, fine. Or maybe I'll just take repeating prompt 1 at face value and just use 1 to 4. That would make life easier. One second. Oh, I'm not charging my phone. Ah! Sorry for the shaky cam. So, yeah, let's just give the upper and lower Darbosums for this parabola. Definitely going to set this up in Wolfram. I don't want to do it by hand. So for n equals 12, our delta x is 3 over 12 is 1/4. Times sigma, I equals 0 to n minus 1 is 11. So let's start with the upper Darbosum. Sorry, I'm getting my blanket on. Oh, okay, well, technically it says do this part technology-less, but I'm going to do tedious calculations with Wolfram Alpha. I won't do the actual integral quite yet, I guess, but I'll do the actual integral at the end to verify my numbers, I guess. So if we want the upper Darbosum from 1 to 4 of a parabola, we want to take the right endpoint of each interval, subinterval. So I think we can still use a similar like like we want I over n as a way to divide up our partitions, and then we still want b minus a is 3. Then we have to offset it by a, which is 1, and then we square it. So like these are each of our x values. Oh wait, this is probably going to get us the lower sum as I wrote it. So I think I want to do I plus 1 for an upper sum. Let's see what that gets us. About 22.9. That seems reasonable. And then for a lower Darboux sum, do just I. About 19, or 13 over 32 versus 733 over 32. Okay. With an arbitrary n, it's something we might have to do by hand here now. No, won't be able to be lazy anymore. Get some water before I go over to the board. Okay. Okay, so, dang it. You know what? Let's do green. We haven't done green in a hot minute. So we're doing, I guess we can start with the upper sum. For arbitrary n. So, it's going to be b minus a is 3 over n, sigma I equals 0 to n minus 1. And then our same thing that we just did. So the upper sum we said is I plus 1 over n, right? Times the range, which is 3, plus the starting point is 1 squared. Okay, good. That is going to be a bit more complicated. So I think we have to just multiply that out. It's the unfortunate reality. That times 2. Plus 1. Okay. We have to multiply that out. It's hard to say that's not -1, the I squared. What is that? 18i plus 9 over n squared. You can actually, it's better to separate that into two fractions, I think. Actually, we'll do that all in the next step. All right, so from this point, the only thing the sum cares about is I. Everything else can kind of get pushed outside of the sum. Or, I mean, not pushed outside, actually. That's bad. Dude, I have to pee so bad. I'm sorry. I need to take a quick break. I'll be right back, everyone. Okay, we're back. Where was I? Actually, did anything happen while I was gone? Nothing? Good. Okay. All right, so we're going to split up the sum. Um, 0 to n minus 1, 9 over n squared plus, ugh, so many sums. None of these are going to be that bad to calculate, I don't think, though. Okay. So this first sum, we need the formula for the sum of squares, which that gave us at some point. I think it'll be easier for me. I can look for it quick. I found it. Okay. So first we have 9 over n squared. So this is sum from I equals 0 to n minus 1, which as far as the sum of squares is concerned is equal to the sum from 1 to n minus 1. So if n minus 1 is our upper bound, we're going to get n minus 1, n, and oh, no, I shouldn't assume it's 2n plus 1. But we have n minus 1, so it's going to be 2n minus 1 plus 1 over 6. Oh, okay, Felix. Let's look at that. Sorry, I forgot. You put that other thing in, and I said I'd look at it, and I didn't. Where's that site again? Found it. There are two different ones? Oh. How do I fix it? Or like where's the Or wait, do I just hit play on this, or do I need to split it up in some way? Just gonna hit play. Ooh. Oh, the one you put earlier was a different one. Man. So that's like the an octagon version of what we just looked at. That's cool. Let me pull up the code that you put before that I forgot about. Just going through your message history. I think I found it. Oh, and with squares. Oh, cool. So I didn't know you could do this with it makes sense, but I didn't realize that you could do it with like that's a really nice shape, like aesthetically. But I guess you can do it for any n-gon. Fancy. That's neat. Sierpinski carpet? Is that what it's called? Or do you just make that up? Oh no, it is called a carpet. Cantor dust? Dude, that sounds like something from like a Dungeons and Dragons game or something, like some kind of item that you can get. Oh. I don't really know what exactly is happening here, but that's a cool name. Whenever I hear Cantor, all I know is Cantor's diagonalization. Oh, that's cool though, Helix. Thanks for sharing that. Making you want to put together a fractals course? I don't know. I never thought of fractals something that were like all that study. Like I always thought it was just like, you know, cool patterns that like you might put for aesthetic appeal. I didn't know that they were something that were like that rigorously like studied, but there's a ton. Oh, okay. Well, that's interesting. Yeah, I know almost nothing about fractals. Okay, so that is that sum, I hope. This is just the regular Gaussian sum, whatever. Which is, it's n plus 1 over 2, but we have n minus 1, so we'll say n minus 1 n over 2. That one is just, there are no i's in there, so we can say it's, we're summing 9 over n squared n many times, so multiply that by n, you get one cancellation, so 9 over n. This is the same deal, it'll be just 6i. That, oh wait, no. Oops. That's another Gauss sum. That is what I was thinking would be just 6. That is going to be n. Nope. Wait. Yes? Yes. Okay. Where does that 9 over n come from? It comes from there. That becomes 6 over n. Wait. Oh, that's a times. Okay. Something didn't feel right, but I think it's okay. You got about 800-page book? Oh my god. It's crazy. Okay, so I guess we're going to multiply the 3 over n in and try to do some simplification. So the 3 will cancel with the 6. Two n minus 1. So the 3 cancel with a 6. That is a 2. One of those n's canceled, so that's just n squared. You good with that? I think I'm good with that. By we, I mean me. So 3 over n comes in here. 3 times 18, 54. Did I actually just, I mean, 54 just feels right. I didn't actually, yeah, it's 54. Okay. Look at me go. N. Yeah. 27 over n squared plus over here. 2n? I think. Wait, n squared. Yeah. 18 over n plus 3. Okay. All right, Felix, it's 1 a.m. there. Yeah, please go to bed. Thanks for hanging out with me. Hope you sleep well. Okay. Now we nearly have a common denominator for all of these. And these 3 all have n minus 1s. So let's work on those. Factor that n minus 1 out. Let's get 18n minus 9. Multiplying the 9 inside the 2n minus 1. Plus 54. Plus 18. We can even get the 2 times 27 in here. 2 times 27 is 54 again. Ooh, interesting. right? We should actually, we should get all these with a common denominator, even if they don't factor that cleanly. So that's going to be, needs 2n. So 36n. That needs 2n squared, so 6n squared. Okay. 18n stays the same. 54 plus 54 is 108. 108 plus 18. 126? 126? 126 minus 9 is 117? That's such a weird number. One 17 isn't prime, 3 goes into it. So maybe it's factorable. I don't know, are we gonna need to factor this? This feels, I kind of want to plug in n equals 12 and see if I get the same number with my Wolfram calculations. I'm sure I didn't make an algebra mistake here. 117 makes me nervous. Browser. So this is my upper sum. I expect if I plug in n equals 12 to get 733 over 32. So let's make a new Wolfram tab. Come on, hurry up. There we go. So I take the last step that I just did and I plug in 12. We get 12 minus 1, 18 times 12 plus 117 plus 36n plus 6n squared. Wait, why am I... 2 times 144. Okay. Come on, be right. Be right. 551 over 32. I did something wrong. Not horribly wrong, I guess. Is that actually double? 733? No. It's a little under, actually. So where did I go wrong? I can't see with the glare. Hey, Richard Cuttingware, this is great. Well, thank you for the kind words. Yeah, the kind of a general shtick that I do is I do like homework help, but if things are slow and no one has a question, then I do like some study questions. So I'm working on this question related to a real analysis class that's being taught on Twitch. That's been kind of fun to like participate in. I realized somewhere in this whole mess of numbers and ends that I made a mistake though, and I'm trying to figure out where exactly in the mess that I went wrong. We could make sure that I did my mental math right, because that's always a good bet that I did my mental math wrong. So I said -9 plus 54 plus 54 plus 18 was 117. It is 117. I didn't do it that badly. Pay yourself 1,500 coffee beans? Yeah, I should. Um, I could even like keep going back through my steps and plugging in 12 for n here until it matches. And then I know whatever step didn't match last was the wrong one? Question mark? I think I like that more than just doing whatever the heck I was about to do. Like going through like step by step, like mentally. Yeah, okay, let's hey Brian, the math Illuminati triangle? Yeah. Sierpinski was a known, you know, triangle enthusiast, so that's pretty suspicious. So let's back up, I guess, a few steps. Let's do like a 3/12 times 9/144 times no, bad fraction. 12 minus 1, 12. 2, 12 minus 1 plus 1 over 6. And I'm good, Brian. How about you? 144. 3 troubles. Yeah, you're right. I'm just kind of like blindly plugging in the work that I have on the board. And I'm trying, I feel like if I do too much stuff in my head, I'm going to mess something up again. Because I made some kind of arithmetic error somewhere in my work. So I'm trying to just plug things in more or less how they look. Plus 6 plus 12. Right? Right, I think right. 733 over, oh wow, I messed up early on. It should be, wait, no, that's right. 730, okay, so no, never mind, I didn't mess up that early on. Okay, so what I found is that this line is good. One of these next lines must not be good. So n squared 3, 2, 9. I like this first part. 18 over n squared times n and n. 18 times 3. It is 54. Checking it again. Okay, I think that does go into that. 9 over n does become 27 over n squared. 6 over n times n squared. There's 2's there. Should that just be n? That's just n. Ooh, thank you for the follow, Richard. Because n cancels with n, then a new n gets introduced from over there. So we have just n there. Okay. So let's fix that part of the work. Because that means this 18 should be 18n. And that does change things, right? Which means we get 36n. And that's 99 if we're taking the 18 away. (108 minus 9 is 99. Okay, so let's plug that last line into Wolfram Alpha with n equals 12 and make sure that this is right. Make sure we didn't make a second mistake somewhere. and then we'll be able to proceed. So 12 minus 1, 36 times 12 plus 99 plus 36 times 12 plus 6 times 144 over 2 times 144. Okay. 793. I'd made a second mistake. Everyone to show work for these kinds of problems? Oh, nice. I apparently could use it right about now. All right, back to the grind, plugging things into each line into Wolfram Alpha. Who knew that arithmetic is so hard? Everyone hates these? Yeah. Because, like, everyone can do it. It's just you mess up one little thing and it throws the entire thing off. Okay. Hey, Linux Physics, if only you had an army of viewers to check your work, imagine if you had 10,000 viewers. Have you tried wearing a bikini? Bikini to solve math problems is quite a long shot. I mean, I'm not opposed. This step is also wrong. You know, a bikini stream is not out of the question. Just say that much, I guess. Okay, stuff inside. Because of string theory? You'd buy that? Isn't that a quote? I'd buy that for $1. How's it going, Malcolm? I swear I've seen some streamer with that as an alert. G-string theory? Exactly, yeah. It's good to hear. 18, 12 minus 1, 12 for 2 times 144. Bikini bottom quarks. 9 over 12. Uh, 6, 12 minus 1, 12. 2 times 12 plus 6 plus 12. Okay, please tell me this was right. 733, 733. Okay. So where's my other mistake? Okay. Somewhere in this line, going from this line to this line, I made a mistake. Somewhere else also. 2n minus 2 plus 1 is 2n minus 1, n minus 1. N cancels with n, so we get n squared there. 3 cancels with the 6 to become 2, the 9 stays there. n cancels with n. So we have n squared there, 2 there. 3 times 18 is 54, n minus 1. What the heck is wrong? (27 over n squared). This entire line looks right to me. I feel like I've been looking at this for too long. Huh. Like, it's one of those things I've been staring at it for so long that I keep making the same mistake over and over again, or keep, like, missing it. I could just erase that line entirely and try to redo it. Show my work more. I guess we're doing that. All right. Okay. Gotta show our work. Ugh, the worst. Who even likes showing work? Okay, so on top we have 3 times 9 times n minus 1 times n times 2n minus 1. 2n minus 2 plus 1. Over 6n cubed, right? Right. 3n times that. 3 times 18, n minus 1, n. 2n squared times n is 2n cubed. 9n times 3 over n is 27 over n squared. 3 times 6 times n minus 1 times n over 2n squared plus 18 over n. I'll get adventurous and actually do that multiplication. N times 3 over n is 3. Okay. Cancel the 3 with the 6. Cancel the n with the n. 2n squared, right? You could cancel the 2 with the 18, but I feel like it'll be easier if you don't. N cancel with the n. 27 over n squared is 27 over n squared. Same here, we'll simply not cancel the 2. You should not cancel the n as well in that case. Yeah. Now, did I make the same mistakes? I feel like I just wrote the same exact thing that I had a second ago. Let's see. Checks out to you? Okay. You know, in that case, I'm not even gonna check it. Let's just send it. Ugh. All right, same procedure. Factor out the n minus 1 from everything that has an n minus 1. 9 gets multiplied inside there. 18n minus 9. That has an n minus 1. It's already over 2n squared, so we can do simple plus 54. That has just an n squared, so multiply it by 2, which is 54. Plus 54. That already has a 2n squared, so we add in the 18n. Now we have no more n minus 1s. That to have 2n squared multiplied by 2n. That needs 2n squared, which is 6n squared. This is what I had before. There's no way this checks out. Wait, let me look. Unless I made a mistake on my original work, and it's supposed to be. Don't multiply. Remember, you're taking limit as n goes to infinity. Oh. Ah! Oh, shoot. My amp. Okay, good. I pulled a little bit too hard on my headphone cord. Okay, yeah, you're right. We could just do the limit as n goes to infinity, like, even at that point. I mean, probably that point is easier. All right, let's just do that. What is... Stop. Goes to infinity of the above is n cubed, same degree on top and bottom. Have a 2 times 9 times 3 over 6. Well, the 6 cancels, so you just get 9. Here you have 0. Here you have 0. Here you have equal degrees. Plus 9? Yeah. 0 plus 3. 21? Do you say 21 or 27? 21. Okay. Oh, okay. Oh. Or L'Hopital it? Oh, yeah. I mean, the trick that I use with leading coefficients is just a shorthand for L'Hopitals. Well, you can do it a different way, too, without. 4 to the 3 over 3 minus 1 to the 3 over 3? That's not 21. Or am I misunderstanding what you're saying, Zach? We do get basically the midpoint of our upper and lower sums. 22.9, 19.1. (63 over 3). Value the integral by the fundamental theorem of calculus? Oh yeah, just like the real way to integrate things. 21, okay. Oh, 4 cubed over 3. I thought I was interpreting it as 4 to the power of 3 over 3. And I was like, that's not right. But no, you mean 4 cubed and then over 3. That makes more sense. And that's what Brian is saying too. Okay. It's so annoying that I apparently did something wrong, but just, I mean, I feel like that was the point, like doing something wrong. So I want to get the actual, like, some kind of clean result with n, but chat's hard. No, I get it. Can't do LaTeX in Twitch chat. You need epsilon? Well, what if I told you I have a whole bunch of math symbols there, which epsilon is a part of? I should remove epsilon, just like mess with anyone who wants to do analysis. Yeah, you can't do that. That's basically what SPQ does. Okay. Start LaTeXing comments. No, you don't have to do that. You don't want. I mean, you can, but I got there in the end with a 4 to the 3 over 3. So I am somewhat tempted to try it with arbitrary bounds. But it gets so tricky when you have negative values and positive values. Like I was having the same issue with the line. Because what you take is, or what end of the sub-interval you want changes. You like latexing, a latexing comment? Maybe I won't do that, because that's already been a mess of algebra. Was there anything else that I skipped over? Oh, okay, yeah, that's right. I was looking at 5, and I was, oh, well, this is, I haven't done the x squared one, so we should do the x squared one. I'm gonna have the same issue here where with x cubed, when x is less than 0, we want the left part of the subinterval, and when x is greater than 0, we want the right part of the subinterval for the upper sum. You may need a few sums along the way. It's a rather long computation. Wait. No. I'm bad at math. Wait. Well, I should draw this out. So think about how we take the infimum and supremum in each subinterval, and maybe I don't need to worry as much as I thought I did. Okay. You know what? Go in my pocket. Or else you're gonna roll away. Spray this thing down. There we go. Okay. Let's go blue. Actually, no, let's go red. I feel like it's gonna make me angry, potentially. So I was debating in my head is that if we divide up x cubed into sub, if we want to take the upper sum, we might run into issues with getting the infimum and supremum for like negative values versus positive values, like we wouldn't be able to do in a what's the word? Consistent way. But I don't think you actually have that issue, because you just always want the right. This is monotonically increasing, so you just always want the right part for the supremum. I'm not drawing this right. I kind of am. Am I? No, I'm not drawing it right, but you do have the problem for a parabola, which I glazed over by just taking 1 to 4. But like, if you have, what the heck am I drawing? If you have like A and B here, suprema are on the left side over here, but they're on the right side over here, and that makes it like harder. But for a cubic, I think you're okay. Yo, hoo, how's it going? Prove integral of e to the x from 0 to t is e to the t minus 1. The pocket messages drawing I don't know if we've gotten to like a proof of something like that yet. So technically, we first need to prove. Oh, we don't need to do it in a particular order, but we would need to prove the upper sum is equal to the lower sum. I don't know if I'm going to do that. A to B. Let's just work on the upper sum. X cubed dx. Is that n? -1? Yeah. Good, but it's time to sleep? All right. Well, get some sleep, Boo. I appreciate you saying hi. Yeah, it's late. Oh, yeah, it's late for you. You should have been in bed already, hoo-hoo. Come on. No, but glad to hear that you're good. I mean, we're also doing the limit as n goes to infinity, so that's why I was getting a little bit tripped up. And actually write that out. That's actually kind of weird that we have two different sums. Two different limits, right? I feel like we should be able to relate those in some way and just do one limit. But from the most important thing. Okay. So delta x is b minus a over n. Keep the limit as n goes to infinity here. All right, so we want to get the supremum of x cubed. I think we do it in the exact same way we did the parabola. So I always want the right side of each subinterval. So we'll take I plus 1 over n times the range b minus a plus a cubed. Okay. Oh, we have to cube that? Dude, this is, yeah, I can see why Zach said it's a long computation. Okay. So I do we? I don't know why I made that noise. God. How do we want to go about cubing this? Do we have to do it the long and painful way? I think we have to do it the long and painful way. So I plus 1 over n b minus a plus a. Just take one of those terms out. Now we'll do a squared. I need more room on the right. No, I don't. Okay. Now I have to multiply this in there. It's just going to be a real pain. So we get I plus 1 cubed b minus a cubed over n cubed. Doing that one to that one to that one now. Now that to that. A in front. a squared in front. Okay. Now the a to all of those. Okay. Could be worse, I guess. It's kind of a mess. Probably already made a mistake, but, you know, who cares? Can we? No, we can't factor out p-minus a's from everything. Okay. So split these up into sums. Oh my god. I just realized what we're going to have to do for this next one. No, we have to be able to do a change of variables or something. Like, we have to multiply out I plus 1 cubed and then do a separate sum for each individual term. Can we take, like, j is equal to I plus 1? Which means j would go from... Like, I want to get rid of that I plus 1 so it's just something cubed. If I did the lower sum, I wouldn't have that problem. So it would just be I. Expanding this cube will generate around 30 terms, while keeping only powers of I that match powers of n. Well, we can't just get rid of the ones that we don't like, though. I think this change of variables will kind of work. Because that means the sum will be from j equals 1. And the upper bound doesn't even matter that much. Like, I guess... up to n minus 2, but even then n goes to infinity. I think that's how we can avoid having to do all that, having to cube a bunch of different things and square a bunch of different things. Wait, would j be -1? That doesn't make any sense. No, j would be -1. That doesn't... No. I'm spouting nonsense. Just call an audible. Make it a lower turbo sum. So I can just get the left part of each subinterval. That seems a lot easier to calculate the lower sum. Because it's literally just you take away the +1. Everything else is the same. All right. When the problem's too hard, just give yourself a different problem. Because it should be the same result for upper or lower regardless. I mean, technically the problem is the task is to prove that, but I'm kind of cheating that. So I can at least do one part of this calculation, I'll be happy. Doing both parts is a lot. So right now I'm distributing, well, distributing is a bad word, but I'm splitting up the sum into different parts, and I'm bringing all the things without I in front as a coefficient. B minus A squared over N squared. 0 to N minus 1 of I squared. Now that one, 2A squared B minus A over N, A equals 0 to N minus 1 of just I, plus I equals 0 to N minus 1 of just A. Okay. Oh, that's what you mean. Yeah, you're right. Algebraic topology is into the chat. Really? I was thinking of like oh, I forgot. It might have been Diophantus equations that are like that. I remember being taught in my history of math class. It was solving something like x squared plus y squared equals like 27 over 10 or some weird fraction. And you can do some kind of weird things with the x's and y's to do with different problem that's easier. And then at the end, you just compensate for the changes that you made. I forget if it was exactly like that, but it was something like that. It was a neat technique that I have completely forgotten. But yeah, I guess it's too late now, but I see what you're saying. Since we're doing with the limit, we could just ignore a lot of the terms. I need the formula for the sum of cubes. I don't have that offhand. Oh, that's like oh my god. It's like the sum of two cubes. I want summation. Sorry, I know my screen capture is messed up right now. I'm just hoping this will be a quick one. N squared, N plus 1 squared over 4. Okay. So B minus A cubed, N cubed times, so that N squared, N plus 1 squared over 4. So we have up to N minus 1 though. So N minus 1 squared, N squared over 4. Okay. Plus 2A B minus A squared over N squared. Times sum of cubes. Did I already forget it? It was like N, oh no, it's N minus 1 though. I think I have it memorized. N minus 1 to N minus 1 over 6. Okay. At this point, we'll just take the limit, I guess. Once we do this next line. So now it's just the normal sum. Oh no. I'm out of room. Where was I in my work? It was there. A squared B minus A times N minus 1 over 2. Okay? Plus that one. That's sum of squares. Normal Gauss sum. Plus, and then A is A N minus 1. Wait, that's not good. Oh no, but we're gonna get the multiplied N by N. Okay, good. Okay. So can we try to do this limit mentally for the sake of my own sanity? On top we get degree 4, on bottom we get degree 4. Coefficient there is 1, coefficient there is b minus a to the 4th over 4. I think I'm okay with that. Over here, n cubed, n squared, n cubed. Okay, so we have another coefficient rule. Plus 2a b minus a cubed over 6. Now we have n squared, 2. Here we have n cubed. That's not good. That's just n? We did not n squared? That's infinity. That shouldn't happen. So this is the third to last term. Which is that one. Which is that one. That's an n squared. So I think I just dropped the squared. Yeah. Wait, why did I do the cube? Wait. That's squared. Why did I do the cube? Wait. That... I thought that was I cubed for some reason. So that's going to come out to 0 then if we're just doing I squared. I feel like I did something wrong. Let's see if I get the right answer, I guess. Because here, degree 2 on top, degree 3 on bottom. So I guess 0. That's weird. All the other ones are equal degree, though. Wait. That's the squared for... Oh, wait. Oh, my God, Suki. Thank you. I can't keep track of my own work. Thank you for that. Let me actually remember to give out a save for once in my life. Okay, so degree 3, b minus a, b minus a cubed over 6. Okay. Degree 2, 2a squared, b minus a squared. The 2's cancel. That's it. Then this one, degree 1, b minus a times a. Okay. This is so much work. Oh my God. I was warned. Okay, so we can factor out a b minus a, but we're still have a b minus a cubed to contend with here. Actually, these at least group. We're going to get some kind of groupings here. Maybe, okay, let's not multiply everything out yet. Let's see where the dust settles after we kind of group things. 4. So that's 2ab minus a cubed. That's ab minus a cubed. They're both over 6. So that's 3a. Right? This one is a squared b minus a squared. That one is a squared b minus a squared. That one's over 2. That one's not. So that's 3 over 3a squared. Minus a squared over 2. That one's just a now. We know b minus a to the 1? Oh, we do. I just didn't factor it out from that one. Okay. This is out. So in theory, we could factor out b minus a from those 3 terms. I don't know. That might save work. I think it saves a bit of work. It's not going to be a huge time saving or anything, but okay. Now let's deal with the very inside part there. Fourth b squared minus 2ab over 4 is 1/2 ab. Three and the 6. Wait, 3 and 6? Oh, 3 and 6. Over 2. Oh no, I'm running into my arrow. The arrow can move, the math can't. Okay. Combining by terms. We don't have any other b squareds. Do we have any ab's? Plus and minus, go away, go away. That's minus 3/4 a squared. That's plus 3a squared. Three quarters, that's 12 over 4. It becomes 9 over 4? I think I'm okay with that. Could be worse. We still have a bunch of algebra to do here. Multiply the b in. Oh no. Okay. Who did that? Oh wait, 3a squared over 2? 3a squared over 2. Really? Isn't that 9 over 4? Can I not do math? Line 2, term 3. Line 2. Oh, that's 3a squared. Oh my god, Stuki. You deserve 1,000,000 saves. Wait, give you at least one. That's about 1,000,000, right? Okay, so that's -3/4 plus 3/2, which is I'm not trusting mental math. Just a half. No? 3? No. No! No. It's 3/4. Times 2/2. Okay, I'm fairly confident that's 3/4. Oh my god, alright. Check chat. Okay, we're good. Probably. Who knows? 1/4 b cubed plus 3/4 a squared b, multiply the a in, minus 1/4 a b squared plus 3/4 a cubed plus a. Oh, dude. Okay. I hope this pans out okay. We're supposed to get what? B to the 4th minus a to the 4th over 4? We're nearly at the last line. We have our 1/4 b to the 4th. Okay, so that's multiplying the b in everywhere. Now we multiply the a in. 1/4 ab cubed minus 3/4 a cubed b plus 1/4 a squared b squared. Is that supposed to be a minus? Oh yeah, it's b minus a. Okay. So wait, that was a times that. So we just do a times that. Oh, and a times that. That is, I guess it's not sus. It's minus 3/4 a to the 4th. That's not good. What cancellations do we get here? I feel like I've gone horribly wrong. A squared, b squared, a squared, b squared. They don't cancel. We get a whole a squared, b squared, though. AB cubed. Those don't cancel. A cubed b? Those cancel. Hey! Plus AB. Yeah. No, I did something very wrong at some point. Shouldn't that be a minus? It's at least something. Who's that? Star Wonders? Thank you for the follow. Welcome in. Just working on a whole mess of a problem here, but don't mind me. So wait, I said that should be minus because that times that, which means negative a times that should turn into a plus, and then the b should make that into a minus. Okay. So do the a cubes b go away now? No, no, their sign matches. And the coefficient of a cubed is definitely wrong. Still, I can't do my fraction math still. Thank you, Star Wonder. I'm doing like a for fun like study problem that's related to a real analysis class that it's being taught on Twitch. This one, it's worth doing, but it's kind of a mess if you can't tell. There's something like, how did I get this out of this? I guess is what I'm investigating. So b minus a squared. So, well, that should be plus 1/4, shouldn't it? Yeah. Because negative a times negative a. Okay. Actually, just wholesale get rid of this crap. The plus a is a big problem because it's the wrong degree. Oh, the plus a on the end here? Yeah, I was like kind of a little suspicious of it. I don't really know what to do about it though. I don't see where I went wrong with it at least. If that does turn into a plus 1/4, how does life change? That becomes negative 1/4 plus 3/2. Which is 5/4. Okay. That's still not right. It should be 1/4. Because you never get an 8 to the 4th any other way. Did I make another error earlier on? Just reviewing my limit taking. Seeing if I missed a coefficient somewhere or something. There's a 2 there. Wait, did I even put it on the right term? Yeah, so it's definitely a 2 there that I didn't bring forward. Did I forget this term entirely? Where's the other upper 6 term? Oh, I combined it. Duh. So that is 4a/6. which is 2a over 3, which turns this stuff into something else. That is terrible, though. Oh my god. Ugh. You gotta be kidding me, dude. The plus a cubed lost its power in the middle of the right side. It did? Oh my god. Thank you so much for helping check this, Stookie. Okay, like, I'd expect to get a lot more cancellations inside here, and we really don't. Which makes me worried that I did something wrong. We could just try, I mean, maybe we could hope that I'm right and see if, even though I'm not getting as many cancellations as I hoped for, that we'll get cancellations later on. We factor in some more of the terms. Or like multiplying more of the terms. AB, AB, minus a half plus 2/3. Is that plus 1/6? It's plus a 6. Wait, so what happened with the a squareds? Oh my god, I'm not doing that. Fraction math in my head. Common denominator is 12. 3 over 12 minus 4 over 12. 8 over 12. $13 over 12? That's such a weird number. No way, right? Did I flip the fraction? No, that's that fraction. Never mind. What is that over 2 and why is that one not over 2? I mean, I lost my own work. That one's over 2, right? So it already has a 2 like built into it where that one doesn't. Is that right? It's from I over n times b minus a times a squared. Yeah, it doesn't have a 2. Okay. I might just give up on this one. It's way too, like, it's hard to spot the mistake. What time is it? 5:30? I'm not sure. I don't know. Dang it! My cough drops. I'm getting tired and like my work is hard to read. Yeah, it's very like fiddly, but either way, Suki, I really appreciate you like checking it and at least improving it, even if it still isn't perfect. Cause I made multiple errors, I guess, but does seem like Dan is live, so maybe we'll go raid Dan. All right, so thanks so much. Actually, I'm cut off the YouTube stream here, so if you're hanging out on YouTube, I appreciate you. Ah, there's 2 of me. Okay. If you're hanging out on YouTube, I appreciate you. I'll be back on YouTube on Saturday, and